Our opening keynote is exploring the blurred frontiers between science and technology. Please welcome Aaron VanDevender, Chief Scientist at Peter Thiel's Founders Fund.
Good morning. It's a pleasure to be here at Pioneers, speaking to you today in Vienna. I am Aaron VanDevender, and I'd like to talk to you about something you may have heard of before, a principle I like to refer to as convergence, digital convergence. But I think that convergence is actually the wrong way to think about it, and so I want to direct the conversation towards digital divergence instead. So some of you may recognize this island. This is Corsica. Actually, is anyone here from Corsica? Nobody? So not too surprising, actually. Through most of history, Corsica has been a fairly out-of-the-way kind of place. Not a whole lot going on there. The great empires of Europe have largely ignored it. Very rugged terrain, and had not very nice things to say about the people that live there. But it's probably the origin of convergence. In about the 1830s, steamships showed up to Corsica, and it cut the travel time between France and Italy and the island about 75%. So what started out as a multi-day sea voyage turned into just a several-hour trip on a steamer. At the same time, the telegraph lines were laid from mainland Europe to the island, enabling real-time communications. So from those two advances, the steamship and the telecommunications, it's almost as if the island itself was moving towards the continent, Corsica converging with France. And over a very short amount of time, it became apparently much closer. Now, of course, plate tectonics being what they are, the island didn't physically move, but to both people who lived on the island and to folks that lived in Marseille, the apparent distance was compressing. Around the same time, there was a gentleman who lived on the island, Angelo Murani. And Angelo was a chemist. And if he had lived in a different time, we probably would have made his chemicals and done some experiments, and we never would have heard about him. But since he lived in that period of convergence, of dramatic opening up of the island, one of his concoctions, Vin Mariani, which included for the first time some tinctures of coca leaves, was popularized on the continent and spread through the world. Now, of course, no one's ever heard of Vin Mariani. Some people call it coca vin, but you probably know it as Coca-Cola. So this was the beginning of what we think of as convergence, the sudden compressing of the world, enabling new technologies and new inventions to gain a global audience. So convergence, though, has made a few promises in the decades that people have talking about it. It's given us some things to look forward to, some hallmarks that the world is actually shrinking in the way that we have been told. The first promise is that place will become irrelevant. If communication and transportation becomes as cheap and as fast and as seamless as we've been led to believe, then it won't matter where you are. The second promise we've been told is the world will come to equilibrium. That if everything is in strong contact with each other, if there's so much mixing, then it must be that the world will find a static equilibrium and everything will be evenly distributed. The third promise of convergence is that big data will save us. That having access to all of the data from innumerable sources around the world, pouring into and available to us wherever we are, will give us the tools to solve innumerable of humankind's problems. Of course, all of these promises are completely wrong. Let's look at why. So the first one, the idea that place will become unimportant, will be irrelevant, is broken because of the power of proximity. So the first way that this promise was promulgated to us was, of course, through the automobile. In the early part of the 20th century, cars were supposed to enable unlimited personal freedom, and the speed at which they traveled and the cost made dramatic improvements. We thought it won't matter where you live or where you work or where you go to seek enjoyment, because as long as you have a car, you can get anywhere, so place will become irrelevant. Of course, we found ourselves just sitting in traffic, and the progress made in the speed of cars ceased to matter. It's hard to tell someone place is irrelevant if there's a 2-hour traffic jam between you and where you're trying to go. And yet, even though we're stuck between places, those between places themselves are lost opportunities. We're on roads disconnected from the places where we are because our mind and our desires are someone else. And that loss of opportunity has broken the promise that place would be irrelevant. There's been a newer wave in the 90s that have tried to convince us that place is irrelevant. Mobile technology, the idea you could be on a mountaintop or on a beach and check your email or attend a teleconference, and that the idea of being tied to any physical location because you have digital technology was very promising and was very seductive. But of course, that didn't happen either. We became more attached to our desks than ever. And the next version, of course, the prophets who tell us that digital convergence will still just wait a little bit longer, make place irrelevant, believe that VR will be the thing that does this. That if you can do anything in the virtual world, then of course it won't matter what's happening in the real one. Of course, this will be a broken promise too. Because all of these digital technologies have, instead of making place irrelevant, have made it more important, have amplified the impact. If we look at Postmates, Airbnb, Uber, Lyft, Amazon Prime, Tinder, Deliveroo, even Pokemon Go. All of these digital services born on the internet, but instead of eliminating the value of geography, they amplify it. And it makes us think more about what are the places that we've been building. Have we been lazy? Have we been making our built environments laid out in repetitive ways that are making it impossible to unlock some of these digital revolutions? We thought we didn't need to pay attention to the physical environment because we would have freedom on the internet. But in fact, the freedom that is in the internet is being imprisoned by the geography in the real world. In fact, this dissonance between what is possible from the internet and digital technologies and what's being realized in the physical world has caused a social movement to be born called YIMBY, which stands for Yes in My Backyard. That advocates for maybe we should be rethinking how we built our cities and transportation infrastructure so that not only can we live better lives in the real world, but we can better take advantage of their digital lives as well. You've all heard the phrase, the future is here now, it's just not well distributed. So now it's time to start thinking about the distribution. We can't rely on just convergence and equilibrium to solve the distribution problem itself. The second promise that's been broken is this idea of equilibrium. It's intuitive to understand in that when boats go through a lock, if you have high water on one side and low water on the other side, and you connect a pipe, then of course the water will flow and the two sides will equilibrate. So we thought if we build transportation and communication technologies, then resources will flow through those and will be evenly distributed as well, and we'll find global equilibrium. But this hasn't happened for two reasons. One, if you do that, you require that every place be the same, then every place is necessarily a clone of every other place. And you lose out on the opportunity to capitalize on whatever is special about the place that you're in. We don't want a world where everywhere looks like everywhere else, where everything is a clone of everywhere else. As otherwise, we'll end up with the lowest common denominator version of everything, strip mall hell. So let's look at some of the places that maybe are different. Some of it has to do with just geography and geology. In the Middle East, of course, tremendous oil reserves give an enormous economic advantage. But there are other things besides just innate geology that lead to specialnesses of place that can, rather than be eliminated by the compressing of the world grow from it. So Shenzhen, China, known as the world's factory, building consumer electronics of every variety. So the naive version of why Shenzhen is a manufacturing powerhouse is just that, well, they have a port, and they had cheap labor. And so it was an easy place to set up factories because there were workers. But now, as we see, the cost of labor has gone up as the standard of living in China has started to approach Western norms. But instead of decelerating, instead of slowing down, Shenzhen is speeding up. Why is that? It's because it wasn't about the labor. It's about the supply chain. The intricate network of component suppliers that are all integrated into each other, even if they're even with the low-cost labor, the ability to dynamically and flexibly create products still gives an enormous advantage. And any new component supplier that wants to enter the market has to join with them, has to have a presence in Shenzhen to join that supply chain network. Of course, every time a new supplier does that, it accretes the value to the city itself. Now, me, as a physicist, when I see these sort of self-reinforcing systems where there's a lot of energy going in and it gets concentrated into a narrow resource, it reminds me of the physics of a laser. Now, a laser is very complicated quantum mechanical entity, but the underlying principle is very simple to understand. It's when you have some sort of non-equilibrium system, like an ionized gas, charged electrons, and you have constraints. And the constraints tell you that there is a one self-reinforcing solution to those constraints. Then all of the energy that's in the big distribution of your ionized gas gets focused down into one wavelength of light, which we see as the brilliant beam of a laser. So you might think of Shenzhen as an electronics component laser. Now, I come from a sort of laser myself from California. This is a map of Silicon Valley, and as we see, there's a heavy concentration, as we know, originally of semiconductor manufacturers like Intel and National Semiconductor that gave it its name. Eventually, that gave way to another sort of economic laser of software companies, and then again, a third sort of economic laser of the venture capital ones. And that may be actually the most enduring and focused of all. If we see on this map, all of the red points are venture capital firms. Not only are they in Silicon Valley, but they're all in a specific road across from one specific restaurant. That's sort of the focus of that industry. Now, for reference, my office is up here in San Francisco, quite a ways from that. So being outside of the self-reinforcing system there, hopefully, is an advantage, and that it allows us to think more originally and be more pioneering in the way that we approach what we do. Of course, where we are today, in Vienna, Austria, even more pioneering. What a terrific location for this type of conference, to think about how can we not be distracted by all of the things that people have been trying over and over again that haven't worked, and be pioneers and look for new solutions. Interestingly, on a logarithmic scale, Founders Fund is exactly halfway between the Rosewood and where we are today in Vienna. And speaking of Vienna and Austria, it has its own internal structure that I think needs to be recognized. If you think of what the country has to offer geologically, you have the Alps and forests, and of course generations of animal husbandry and some exquisite culinary expertise. And so you put that all together in a self-reinforcing system, and of course we get the sausages that the city is famous for, and lunch meats. The Austrian National Tourist Office calls the country Europe's deli shop, but I actually think Europe's meat laser might be a better term. So the third promise that's been broken is that big data will save us all. And it's important to recognize that actually the things that have really mattered aren't the big volumes of data, but the small significances. So DeepMind, a company that we were the first investors in, that tried to build artificial intelligence systems, and before they were acquired by Google, they built a software that was capable of playing Go, an extremely complex board game that had been thought for a long time to be sort of uncrackable by software agents. And their idea was, if we could take a software program that could study every game that had ever been played by humans, millions of games which are available online, and learn all of them, we could build a superhuman champion. So of course they did that, and their program was able to successfully beat Lee Sedol, one of the great players of all time and a grandmaster. Of course, after achieving this, they realized maybe this isn't the best way to go. Maybe understanding all of these games that humans have played actually teaches us the mistakes that humans have been making, learns their bad habits. And most of the players out there are not very good. So you're training off of amateurs, people who don't know what they're doing. So instead they decided, let's go from big data solution, all of the games available, to the zero data solution. They had the computer just play itself with no exposure to any previous known strategies in the game. And not only was it able to destroy all known human players and all artificial intelligent players in Go, but can do the same feat in chess and in shogi too. So the zero data solution was much better than the big data solution. But it is very tempting. And as we can see, the sort of race to get more and more data into these systems as time goes on is seductive. The self-driving car companies do this, where they compete for how many road miles each of them has exposed to their system. So Waymo's 350,000 road miles. And the idea here is that maybe there's some number of miles that when we get to, the cars will wake up and be safe to allow to drive autonomously on the streets. And maybe that's 1 million or 10 million or 50 million. But I can tell you with certainty that actually there is no such threshold. And we are way past what's necessary. Most of those road miles are completely redundant. In fact, driving is so boring and repetitive and monotonous, it may be the only thing that humans participate in that's incredibly deadly, and we fall asleep doing it regularly. But we know that's well over what's required to do, because we teach teenagers to drive, we give them keys to the cars, with only maybe 50 road miles of experience. So if our algorithm takes 50 million and a teenager takes 50, we can conclude that our software is 1 million times worse than the average teenager. And I'm pretty sure we don't want autonomous vehicles driving around that are 1 million times stupider than the average teenager. It's also easy to make this mistake in biology, where we have genetic sequencing machines that give us enormous amounts of data on human genomes at the both individual and population level. But most of it is, again, extremely repetitive and noisy. If you want to diagnose whether someone has the gene for breast cancer propensity, it's only a handful of bases that really matters, only a few bits, and all of the rest of it is irrelevant. It's the small differences that matter between life and death. The biggest example of this, of course, though, is the quantum computer. So we've been developing these machines which can hopefully give us the capability with just 1 million or 10 million qubits to have more computational power than all the world's current computers combined. But the types of problems that they can tell us aren't big data problems. They're not about looking at everything that's out there. They're about getting the most work out of the smallest data you can. This is a Commodore 64. It was my first computer in the 80s. Has only 64K of memory. Can easily hold the chemical formula for a large molecule, or even, say, your private key to encrypt all of your email. But even though it can store those things, it can't possibly hope to understand them. But it's a quantum computer is the type of thing, is a technology that can. And so in the future, as we look towards the compressing world, these type of divergent, not convergent technologies like quantum computing will show more results with the small data than we were ever able to get with the big data approach. So digital divergence. Unfortunately, the prophets that told us about digital convergence were wrong. None of those promises came to fruition. But it's okay, because the world we end up with is actually much more interesting and much more useful than the one that we were supposed to have. Because proximity is powerful. Because non-equilibrium diversity is much more interesting. And because it's the small differences at the end of the day that really matter. Thank you very much.
Thank you very much, Aaron. Well done.
My pleasure.
Now, we have some questions, I believe, from Slido. So let me open this guy up here. I hope you all ask questions. And we have a question by Anonymous.
Those are the best kind.
Yes. As a quantum physicist and investor, do you see a lot of applications of quantum science in the startup world applicable for today's problems?
Yes, absolutely. And both in two different ways. One is that the universe that we live in is fundamentally quantum mechanical. And so even if you're not wrestling with the quantum mechanical nature all of the time, the intuition that comes from that understanding is still relevant, since everything else that we have is built on that foundation. The second thing is, in the early days of developing quantum computers, we weren't sure what was going to be the silicon equivalent or the transistor equivalent. And there were many quantum systems that were proposed, like optics and superconductors and biological molecules. And so we built reference quantum computers on all these different model systems. And it turns out that many years later, many of the breakthrough technologies in other industries are built on the same fundamental technologies and sciences that we use to build quantum computing prototypes. So it does actually translate in a weird way.
OK, excellent. Speaking of quantum computing, for the second question, is the robot guy controlled by a human? I think we're going to leave that as a Schrodinger's cat situation. We're not going to open up the box and let you know, because we're all about blurred frontiers. So maybe, maybe not. But it's for you to wonder, not for me to say. But I can tell you, I think Pepper's a she. What do you think, a he or a she?
I think so.
Right?
Yeah.
Yeah, definitely. OK, all right, well, thank you very much.
My pleasure.
All right, a round of applause for Aaron. Cheers.